Hello everyone, and welcome back to the Flectus channel. Anchors have been around almost as long as ships have, and for very good reason. Typically made of heavy metal, anchors are specifically designed to tether a ship to the seafloor. Though there are many different designs, they generally feature two or more flukes, or hooks, which grip the seabed, keeping the vessel from drifting in rough water or heavy wind. Of course, one of the general rules of anchors is that the bigger the ship, the bigger the anchor must be. So, when it comes to mooring 1,000-foot-long, 100,000-ton aircraft carriers, the anchor and chain must be absolutely massive. In fact, the average aircraft carrier anchor weighs around 30,000 pounds and features a chain that's roughly 1,440 feet long. And since these components have such an important job, they need to be evaluated frequently via practices like the anchor drop test. Large ships, like aircraft carriers, aren't designed to have their anchors simply thrown overboard. Instead, they feature a robust mechanical system that covers multiple rooms of the ship. The bottommost room is known as the chain locker. This is where the hundreds of feet of the chain are stored when the ship is underway. The chain locker and chain are connected via a shaft to the windlass room. In aircraft carriers, which often feature two anchors, there is one windlass room at the bow and one at the stern. In each room, a large winch, known as a windlass, controls the dropping and hoisting of the anchor as it turns. In order to grip the anchor, it is equipped with special drums known as wildcats. These also act as a braking system when the anchor is dropped.
When you do the anchor drop test, it's to make sure there's no deficiencies wrong with the anchor. So you drop it, lower it in the water with the wildcats engaged, and then after you test that, you bring it back up, and then you disengage it, you free fall it, stop it, so you set the brake, and it's got a certain amount of play it can give, and then you do it again to a different depth, which would be 30 fathoms, and after that we bring the anchor back up, bring that 30 fathom mark around the wildcat, drop back down, set the brake again, and then if it sets at between a certain distance, it's good to go.
Both anchors and anchor chains are exposed to significant stress during operation. Even though they are typically made of high-strength steel, the combination of friction during dropping and hoisting and exposure to corrosive salt water can weaken the chain's links and potentially cause breakage. That's why anchor chains occasionally need to undergo repairs, both while docked and underway. This is usually done via a process simply known as a manual check. When the ship is underway, this will be done in the windlass room, or the chain locker, which can be extremely challenging. In port, the entire chain can be laid on the dock to evaluate the links individually. The goal is to ensure there are no weak points, cracks, or other issues that might cause the anchor to fail. This includes checking all links and shackles and securing loose pins connecting anchor sections. Were these crewmen to miss a weak point, it could drastically impact the vessel's ability to fulfill its mission safely. The anchor is far from the only part of the aircraft carrier that needs regular inspection and maintenance. These vessels boast millions of moving parts that must stay in tip-top shape if the vessel is to do its job. From elevators that move planes from the hangar to the deck, to catapults and retractable blast shields. Every inch of these ships is vital to its operation. One of the most important systems on the flight deck is the arresting gear. This is the specialized system used to decelerate aircraft as they land rapidly. In use for decades now, the arresting gear system consists of a tailhook attached to the frame of the airplane and a hydraulically powered line stretched out horizontally over the deck. As the plane touches down the flight deck, the tailhook engages the line and pulls it forward. At the same time, kinetic energy is transferred to hydraulics located below the deck. Using this system, planes can be brought to a safe stop in just a few hundred feet or less. Under their own power, they would typically require an entire runway to come to a stop. Arresting cables have been used by the Navy in one way or another since the early 1900s. However, these systems do not just have applications aboard ships. For instance, the United States Air Force has been developing land-based arresting gear systems for decades. But while these systems can be used to speed up the landing process, they are instead intended to aid aircraft that are coming in for an emergency landing and might not be able to stop otherwise. Over the years, the Air Force has inspected several different arresting systems, from nets to safety barriers. However, the design to see the most widespread use is actually very similar to those installed aboard ships. It is the BAK-12, which stands for Barrier Arresting Kit. This unit consists of a steel line stretched over the runway, elevated by a series of small wheels. Just as with aircraft carrier landings, planes are equipped with deployable tow hooks, which can grip the line during landing. That line is connected to a multi-disc rotary energy absorber, which helps bring aircraft to a safe but rapid stop. In recent years, the Air Force has mandated trainings on the BAK-12 so that all pilots can be certified in performing these short-distance landings.
We are doing a certification on our BAK-12 systems, the aircraft arresting system. The BAK-12 system is used for catching aircrafts, basically. The importance of this is that if we don't have a system like this in place and there's some kind of aircraft emergency, in-flight emergency, this system is here to stop that aircraft from possibly crashing, saving the pilot's life and saving the aircraft. So once a tailhook aircraft has an in-flight emergency, the tailhook from the aircraft hits down, catches the pendant, pulling the tape, which causes the brig to hold, slowing down the aircraft and eventually stopping it.
In order to bring a plane weighing tens of thousands of pounds to a safe stop in an emergency, the kinetic braking system on the VA-K-12 needs to be exceptionally well maintained. After all, landings like this put tremendous strain on the various components, and great care needs to be taken to ensure that the line does not snap. If it were to break, it would put the pilot, aircraft, and ground crews in grave danger. For that reason, maintenance and maintenance training are a regular operation at VA-K-12 equipped airfields worldwide. One of the primary ways this is accomplished is by having a tractor or other heavy-duty vehicle repeatedly test the strength and durability of the cable. As the line is pulled, technicians can evaluate the performance of the energy absorber to make sure it's working as intended and make any repairs if necessary. Aircraft safety is essential to any military organization's mission, especially during the highly dangerous process of landing. Even though the vehicles are expensive, the actual value can be found in the lives of the pilots and crew members operating them. Similarly, it is imperative that aircraft carriers and other large vessels be able to secure themselves to the ocean floor to prevent damage during mooring or an emergency at sea.